Linux and Fundamentals Part 4. This episode has 18 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. What is RBAC? Here's a strong way to approach it. RBAC, role-based access control, in Kubernetes is a security mechanism that controls who can do what inside a cluster based on roles. Core idea. RBAC answers who is allowed to perform which actions on which resources. It is used to enforce fine-grained access control in Kubernetes. Why RBAC is needed in a cluster. Many users and applications exist. Not everyone should have full access. Security must follow least privilege principle. RBAC ensures only authorized users or pods can perform actions. Sensitive resources are protected. Main components of RBAC. 1. Role defines permissions within a namespace. Example: can read pods, can list services. Kind. Role rules, API groups, resources, pods. Verbs: get, list. 2. Cluster role, same as role, but cluster-wide scope used for nodes. Persistent volumes. Cluster-wide resources. 3. Role binding connects a role user or group or service account. Example: kind. Role binding subjects. Kind. Service account name. Apps a role ref. Kind. Role name. Pod reader. 4. Cluster role binding binds a cluster role at cluster level. How RBAC works. Flow. 1. User or pod makes a request to API server. 2. Kuba API server checks authentication. 3. RBAC system checks authorization. Is this user allowed? 4. If yes, request allowed. 5. If no, request denied. Key RBAC concepts. Verbs: actions, get, list, create, update, delete, watch, resources, pod, services, deployment, secrets. Example scenario: you want a pod to only read pods. Create role pod reader. Create role binding attached to service account. Result: pod can list pods, cannot delete or modify anything. RBAC versus ABAC. Old system. Feature: RBAC ABAC based on roles. Attributes: complexity, simple, complex usage. Standard, deprecated, simple. Analogy: think of RBAC like a building. Roles equals job positions. Admin, developer, viewer. Permissions equals what each job can access. Role binding equals assigning a badge to a person. Best practices: use least privilege, avoid giving cluster admin unless necessary, use service accounts for apps, separate roles per namespace, regularly audit permissions. Interview ready. Definition: RBAC in Kubernetes is a security model that regulates access to cluster resources by assigning permissions to roles and binding them to users, groups, or service accounts, ensuring controlled and least privilege access to the Kubernetes API. Nice. Let's continue. Question 2. What is the difference between a role and a cluster role in Kubernetes RBAC? Here's a strong way to approach it. A role grants permissions scope to a single namespace and is paired with a role binding. A cluster role grants permissions cluster-wide, or can be bound within a single namespace via a role binding too, and is paired with a cluster role binding for cluster-wide access. Use cluster role for cluster scope resources, like nodes, or when the same permission set needs to be reused across many namespaces. Great. Moving on. Question 3. What is the difference between a role binding and a cluster role binding in Kubernetes? Here's a strong way to approach it. A role binding grants the permissions in a role, or cluster role, to a user or group or service account within one specific namespace only. A cluster role binding grants the permissions in a cluster role across the entire cluster, all namespaces included, so the binding controls the scope of access even when it references the same underlying role. Alright, next question. Question 4. What is GKE workload identity? Here's a strong way to approach it. Workload identity lets a Kubernetes service account in GKE impersonate a Google Cloud IAM service account without storing any exported JSON key on the cluster. Pods use their Kubernetes service account to obtain short-lived Google credentials automatically, which is the recommended, more secure alternative to mounting service account key files as secrets. Let's keep going. Question 5. What is the difference between a stateful and a stateless application? Here's a strong way to approach it. A stateless application doesn't retain data between requests. Any instance can handle any request, making it trivial to scale horizontally and replace. A stateful application persists data, in memory or on disk, tied to a specific instance, like a database, requiring stable identity, persistent storage, and careful handling during scaling or failover. which is exactly what Kubernetes stateful sets are designed for. On to the next one. Question 6. What is a secret, in the context of Kubernetes or cloud platforms? Here's a strong way to approach it. A secret is a piece of sensitive data, passwords, API keys, TLS certificates, tokens, stored and transmitted separately from application code or config, typically encrypted at rest and access controlled, rather than hard-coded or committed to source control. Good. Here's another one. Question 7. What is autoscaling? Here's a strong way to approach it. Autoscaling automatically adjusts the number of running instances or pods up or down based on real-time metrics like CPU, memory, or request rate, so capacity matches actual demand without manual intervention. Nice. Let's continue. Question 8. What is the difference between horizontal and vertical scaling? Here's a strong way to approach it. Horizontal scaling adds more instances or pods running in parallel to handle more load. Vertical scaling increases the resources, CPU, memory of an existing instance. Horizontal scaling is generally preferred in cloud-native systems since it avoids a hard ceiling and single points of failure. Great. Moving on. Question 9. What is a reverse proxy? Here's a strong way to approach it. A reverse proxy sits in front of backend servers and forwards client requests to them, commonly used for load balancing, TLS termination, caching, and hiding backend topology from clients. Alright, next question. Question 10. What is TLS or SSL? Here's a strong way to approach it. TLS, the successor to SSL, is a cryptographic protocol that encrypts data in transit between a client and server and verifies server identity via certificates, which is what makes HTTPS secure. Let's keep going. Question 11. What is a container registry? Here's a strong way to approach it. A container registry is a storage and distribution service for container images, like Docker Hub, Artifact Registry, or ECR, where images are pushed after a build and pulled from when deploying. On to the next one. Question 12. What is Artifact Registry? Here's a strong way to approach it. Artifact Registry is Google Cloud's managed service for storing and managing container images, language packages, NPM, Maven, Python, and other build artifacts, with per repository IAM, vulnerability scanning, and regional replication. It's the successor to the older container registry. Good. Here's another one. Question 13. What is cloud build, and what does a typical cloud build workflow look like? Here's a strong way to approach it. Cloud build is Google Cloud's managed CI or CD service that executes build steps defined in a cloud build YAML, or Docker file, as a sequence of containerized steps. A typical workflow: a trigger fires on a Git push, cloud build checks out the code, builds a container image, runs tests and vulnerability scans, pushes the image to Artifact Registry, then deploys it to Cloud Run, GKE, or via Cloud Deploy, each step running in its own container for isolation. Nice. Let's continue. Question 14. What is Cloud Deploy? Here's a strong way to approach it. Cloud Deploy is Google Cloud's managed continuous delivery service for orchestrating progressive, multi-stage rollouts, dev to staging to prod, to GKE or Cloud Run, handling promotion approvals, canary or rolling delivery strategies, and rollback, on top of artifacts already built, typically by Cloud Build. Great. Moving on. Question 15. How does Cloud Armor work to protect a service? Here's a strong way to approach it. Cloud Armor is a Google Cloud WAF and DDoS protection service that attaches to an external HTTPS load balancer and evaluates incoming requests against configured rules, IP allow or deny lists, geo-based restrictions, pre-configured WAF rules, SCLI, XSS, and rate limiting, blocking or throttling malicious traffic before it ever reaches your backend. Alright, next question. Question 16. What is a rollback? Here's a strong way to approach it. A rollback reverts a deployment to its previous known good version after a bad release, typically by redeploying the prior image or version or, in Kubernetes, Using the deployment's revision history. Let's keep going. Question 17. What is a blue-green deployment? Here's a strong way to approach it. Blue-green deployment runs two identical production environments. Blue equals current, green equals new. Traffic is switched all at once from blue to green after the new version is verified, allowing an instant rollback by switching traffic back. On to the next one. Question 18. What is a canary deployment? Here's a strong way to approach it. A canary deployment gradually shifts a small percentage of production traffic to a new version first, monitoring for errors before progressively increasing traffic, limiting the blast radius of a bad release. Good. Here's another one. That wraps up this episode. Nice work practicing, and see you in the next one.